What?
Hey guys, Robin here, and Goldfish, and today we have a special guest.
It's me, James. G'day.
This is Dr. James Tanton, mathematician at large. No, really, that's his actual title. He's part of the Global Math Project team, and he's the creator of exploding dots. Want a banana? We know how to make a base 2 machine. We put in a bunch of dots and start doing explosions. But did you ever wonder which explosion to do next? I could do this explosion next, or I could do this explosion over here. Doesn't matter which one I do first. It always seems to work out right in the end, but how can you be so sure? That's what we're going to talk about in this video.
Alright, so your question is about order, does it matter or not when you do explosions? So just to be clear so I understand what's going on, because I'm very slow at these things. Alright, so just to make sure I understand, here are 7 dots in a 2-1 machine. And we can explode by doing 2 dots kapow and 1, 2 dots kapow and then 1. And most of the time we keep going till this box is done. But what if instead I wait and do this box instead? Kapow. Am I sure to get the same answer in the end as if I did everything from the left box at the beginning? Is that the question?
Yes.
And you think the answer is yes? You will get the same thing?
Yes.
Wow, that seems hard to think about. If I put in that many dots, how can we get our brains to think around that?
Let's think about it.
Yeah, let's think about it. So let's think.
Here's the first thing we noticed. If you added the value of the dots after each explosion, we notice that the value always stays the same. Alright, right now all the dots are in the ones box. So each dot is equals 1. So that would be 1, 2, 3, 4, 5, 6, 7.
Alright,
7 ones, that's 1, correct?
Got it. 7 ones is 7. Beautiful.
Okay, so now I'm going to do an explosion.
Kaboom! Excellent. All right. Now, before we do any more explosions, we're going to add these up. Is that right?
Yes. Yes. So basically, we have 5 in the ones box. That's equals 5 and 2, and 1 in the twos box. That's equals to 2, and 5 and 2 equals 7. So it still equals 7.
Okay. Okay. Then show me another explosion.
Now let's do another explosion. So now we have 3 in the ones box, and 2 in the twos box. That's 4 and 3, which would equal 7.
Okay. I dare you to do one more explosion, but do the one we don't expect.
Okay. Instead of waiting for us to have 1 or none in this box, we're gonna do the twos box. Now we have a 4 and a 3. That is 7.
So it always seems to be staying at 7. Cool.
And let's do another explosion. That is 7, because that's a 1, a 2, and a 4.
That's still 7. It's always 7.
Well, why does this happen? What's the phenomenon going on that causes this?
That's the next question. You're right. More thinking.
Fun time! Observation 2. Pick any explosion in any box.
one dot is removed, but the remaining dot is multiplied by 2 when we move it to the left. So the value stays the same through every explosion. Okay, so here's what we figured out.
Cool.
We know that this is the 1's box, this is the 2's box, this is the 4's box, this is the 8's box, and this is the 16's box. It's multiplied by 2 every time. So, because of that, we know that we can tune the rule. 2 1's goes to 1 2. They're the same. So the rule doesn't actually change the amount that's represented by the dots. It just changes the appearance of how it's represented.
So let me sure I understand, because that was very clever. So I've got 2 1's, and they become 1 dot over here. It's like I put the 2 1's on top of each other, but I can't see that. It looks like 1 dot here, but still actually worth 2 1's. But now 2 1's, of course, is 2, so it's like having 1 dot worth 2.
Yeah.
Is that it?
And then if you have 2 dots here,
Yeah.
if you have 2 dots here,
So there's now 2 2's.
which is 4, you can have 2 2's, or you can have
1 4. Right, okay, so when you do an explosion, when you add up all the numbers they represent, nothing's actually changing. So of course it stays the same number when you add up all the values all along. Wow.
Back to the question of order. So if the explosions don't affect the value, then the order we do them in won't affect the value either. I could do this explosion first, and the value stays the same. Or, I could do this explosion first, and the value stays the same. Okay, so maybe order doesn't affect value, but maybe it affects other things. So we're not done yet.
Like, how do you know if you have 7,
That's
will
a really
that go
good
on
question to me.
forever?
I want to know, will this ever go on forever? Why must this process of exploding stop?
Okay, time for thinking again. Fun time! Observation 3. The explosions will stop eventually because each explosion removes one of the original dots. Because we can't put infinite dots in this box, there will be a finite number of explosions. In every explosion, we lose 1 dot. So that means that the number of dots will keep going down until we don't have enough dots to keep doing explosions with.
So I understand. Help me out. You started with 8 dots, and you say every time you do an explosion, you lose a dot. So that means we could do at most, 7 explosions?
Yeah, I think that's how many. 1.
And did 7 actually happen?
2, 3, 4, 5, 6, 7. Yes, you can only do 7 because it'll eventually run out of dots.
So if we start with 13 dots in that box, that means we'll do at most 12 explosions, because every explosion loses a dot?
Let's see. There.
Oops.
There we go. No, I got it fine. And I wasn't. Wait, so 4.
Uh-oh, how many explosions was that?
Yes, okay. We can cut that part out. I'll just redo
Right,
it.
so that really was 13, so just check we got that right. Yep,
Yes.
that's 13, yep.
Okay, so let's see if we actually get 12, like
Okay.
the last one.
1 explosion, 2 explosions, 3 explosions, 4 explosions, 5 explosions, 6 explosions, 7 explosions, 8 explosions, 9 explosions, 10 explosions!
So the amount is always going to be how many you have here, because every explosion you lose one, right?
Correct, that
Okay.
makes sense. Now that's interesting, so we argue there's going to be at most 12 explosions, but it could be less. In this case it was less, it was only 10. Alright, so now this is a big question. Can you predict how many explosions there are going to be for each number? Because that was a surprise to see it was only 10 then.
Without already doing it?
So
Without actually having to
I
go
guess
through the
we
work
could-
of doing it. Yeah.
look at the
you're
pattern.
technically going through it in your head.
We could do it in
So
your head.
13 is 10, and
Alright, what's 7,007 going to be? Exactly.
Okay, so that's a challenge. So try to see if you can figure that out at home.
Okay, another walk. I can feel myself going for a good walk now.
Fun time! So here's what we learned today. 1. The total sum value of the dots never changes. It's always the original number. Number 2. The explosions will stop in some configurations of zeros and ones. How do we know it's the same configurations of zeros and ones? We need a third piece. A number can only be one configuration of zeros and ones. That is going to be another video. Thanks for watching. Bye, guys.
Fun time!
I'm going to...
Any questions?
Oh.
And there are bananas! Whoa, what could be better? Math and bananas.
I'm wearing skinny jeans. How am I supposed to do this?